IRR is a very powerful concept, and knowing how to calculate it can be very useful in determining which of a selection of deals is the better one. And so to demonstrate that, I will propose you a couple of examples. Say someone comes to you with the following deal. You will pay out $1,000 for 10 years, represented here by these cash flows in red. And then after that, the company will pay you $1,000 every year for 20 years, effectively doubling your money after 30 years. But then another individual comes to you and insists that this other deal is certainly much better. You will pay varying amounts of money over 14 years, and then in the following 16 years, the company will pay you back varying amounts of money. And the total amount of money that you get will be $23,000 after an outset of $10,000. So this deal will more than double your money. Surely it seems deal 2 must be the superior deal. But one important perspective to bring to this is, well, what makes a company good? I propose that generally a better company will be able to turn money into more money better. So how do we represent this? How do we calculate this? How do we think about this? Well, I'll start with deal 1, which is in fact a simpler deal, I think. And I want to simulate an account. This will be the simulated account of the company that's taking your money, that you're investing with. And we're going to simulate the account value over time. But what we're also going to add to this account simulation is an interest rate. This is the rate at which the company is able to turn money into more money. And I'll just put it in a box over here. And there it is. So what we can do is we can simulate this account value, assuming some interest rate. Now, the interest rate you start with is kind of arbitrary. We don't know what interest rate the company is going to be able to maintain internally. We're just going to guess at 5% and see what happens with the account value. So for the first year, I follow the convention that interest does apply. So we negate the cash flow because when it's coming from you, it's negative, but if it's going into the account, it's positive. So we have negative the account value times 1 plus the interest rate. Okay, that looks right. And then for the next box, it's a little bit more complicated. We take the previous value, subtract the cash flow, and then multiply the new value, or apply interest to the new value. Okay, that looks right. Oh, then one thing that's very important to do, because we're going to be copying this formula, we want to make this reference an absolute reference, so it doesn't change as we're copying it down. Okay, there we go. We've successfully simulated the account value. And at the end, we got about $300 left over, which means our guess of 5% is pretty decent. Okay, so let's try the same thing over here in deal 2. In theory, it should be as easy as just copying this. Okay. So we look at deal 2, And we see that in this account value simulation at the same interest rate as deal 1, the company's account value actually ends up being much bigger than in the other case. So this would imply that the company for deal 2 is keeping more money than the company in deal 1. But it's hard to know precisely how to express this. Ideally, we could find the exact interest rate that makes this account value come to 0. And if we did that, then we would know exactly what rate of return you're getting. So the way to do this is to calculate the IRR. And you can do that with a formula. And your input to the IRR formula is this sequence of cash flows. And there we go. Now we have the IRR. So it turns out that our guess of 5% was very close. And just to sort of verify this IRR being right, we could set this interest rate equal to the IRR. And we expect that the account value comes to 0, or approximately 0, which it does. Now, if we repeat the same process with deal 2, we would say deal 2 is worse if the IRR is lower. As it turns out, it is significantly lower. Assuming it's correct, so we check it. Yep, that looks right. So despite the fact that deal 2 gives you more than double your money, it has a lower rate of return by more than a whole percentage point. But hang on a second. This deal gives me more money at the end of the day. And, well, if you're a smart investor, presumably you want more money rather than less money, right? So if you find this sequence of cash flows attractive, perhaps what you could do is come back over to company 1, who gave you this initial deal, and say, okay, I know based on this sequence of cash flows that you can generate money at a rate of 4.93%. And we get rid of the IRR here because we assume we know. We know the interest rate. And you say to them, well, I don't like this sequence of cash flows. What if I presented you with a different sequence? And now you could take a look at their account value that you've simulated here, assuming that you've correctly assessed their interest rate, which is reasonable. And then you could modify this a little bit and say, well, hold on, I know that they are going to end up with $6,000 excess in their account. So perhaps a mutually beneficial deal is I can just modify this last cash flow to be 11,000. And at the end of the day, they end up with $400 extra, and I end up with, what, $6,000 more than I was initially expecting, now almost tripling my money. And most likely, the company 1 would look at this deal and say, oh, well, not only is this better for me, but this is also better for you. And everyone's happy at the end of the day.